Hello and welcome to another video of Wise Interactive Learning. In this video, we are going to see what is logarithmic differentiation. But before that, we need to see few log rules which are very important and basic for solving such kind of differentiation questions. For example, log of a times b will be log of a plus log of b. So this is a very basic formula which everyone should understand. At the same time, log of a upon b or divided by b will be log of a minus log of b. So if you knew these two formulas, it will be very beneficial and it will be very easy to understand why we are using log for a differentiation question, right? Okay, so as far as we know, we have understood what is product rule, right? So product rule is nothing but when two functions are multiplied, for example sin x times cos x. So here you use product rule, which we state it as this as u and this as v. So we have the differentiation as u dash v plus v dash u, and we can get around this by solving such kind of examples when we have two functions. We also saw a rule before this which is called as chain rule, or rather what we called as from my technique, which is box rule, which was when you have a single function but it has multiple layers. For example, sine of, tan of, log x. So here you can see that there are multiple functions, but the overall function can be stated as a comparative of a sine function. So here you only have sine, and then inside you have all kinds of tan and log x. So for this we have used a technique which we call as box or chain rule, where we first differentiate the outer side function. So we have cos of inside, then times, then we go to tan, which is sec square, then we again go to log, which is 1 upon x. So in these kinds of examples we have seen how to solve examples based on such different functions. But how can we solve a function which is f of x raised to f of x, or rather let's just say sine of x raised to cos of x? Well, in this case all other formulas are going to fail, and here a formula comes which is, or rather a technique comes, which is the logarithmic differentiation. And now we'll see what is logarithmic differentiation. For example, let's say you have y equals to x raised to x, right? So then what will be the first step? Well, the first step is that we need to simplify this x raised to x in such a way that we can easily differentiate it, right? So what we need to understand is we need to simplify this x raised to x, and if we simplify this we can easily find the answer. So taking log on both sides, obviously we actually don't change the entire function. For example, whatever equation you take, if we apply log on the both sides, it is not going to change. So what we have after applying log is log of y equals to log of x raised to x. And now here another log formula which you need to understand is log of a raised to b is nothing but b log of a. So this is a basic formula which everyone needs to understand. So here we can simplify this as x log of x, and now you can see here that this is nothing but a product rule question, which is u times v, and this is nothing but a chain rule. So differentiation, now we will differentiate on both sides. So differentiation of log y will be 1 upon y times dy upon dx, and what are we looking for in this question is dy upon dx. So we want only this particular equation, dy upon dx. So here we'll take differentiation of x first and keep log x as constant. So differentiation of x is 1, so we have log x times 1 plus, now we need to keep x as constant, and then differentiate log of x, which is 1 upon x. So x gets cancelled. This is 1 plus log of x. But now watch carefully what we have on the left side. We have y in the denominator and dy upon dx. So we want only dy upon dx. So we multiply y on this side and we have our answer, which is dy upon dx is equals to y. What is y? Y is nothing but, in the first equation we have over here, x raised to x. So the answer is dy upon dx will be x raised to x 1 plus log of x. So this is your very basic and very simple example of how to use logarithmic differentiation. Now we'll see few more examples. Okay, now I'm going to specifically tell you how can you know when to use logarithmic differentiation, when to use chain rule, when to use inverse trigonometric functions differentiation and other stuff. So we'll start with this first example, which is y equals to x raised to 3x times sine square x times log x. Now if you watch carefully, you can actually apply product rule over here by taking two terms at the same time. So you can take x raised to 3x as u, and then you can take sine square x times log x as v. But it is going to be a tedious and a complicated process to handle, right? Here, instead what we can do is, since we have the power as 3x and x in the the base, so it is going to be difficult to solve such examples. And only if we take logarithms or log on the both sides, it is going to be easily converted into a simpler form, right? So the main objective or the main understanding purpose behind solving the logarithmic differentiation is nothing but you need to understand how to make the functions less complicated. So the only purpose of doing this logarithmic differentiation is to make the functions less complicated, or in other words you can say it as simpler, right? Again, in the second example over here, we have a function which is sine of x plus cos of x raised to 1 plus tan x, and no matter which formula you apply over here, it is not going to fit in this system, and you're most probably going to fail to do this differentiation without using log. So first we'll check what is the first example. So if we take log on both sides, we have log of y equals to, now when you apply log on both sides, we are directly going towards the step which is of log of a times b, which is log of a plus log b, right? So we have mentioned that step over here. So this step, if you look at this step carefully, you will understand that it is easily convertible into this form. So when you apply log to x raised to 3x, it will be 3x log of x plus, the 2 can come down, so you have 2 log of sine x, then again you have plus log of x, so again log of x, right? And now when you differentiate this, it will be easy for you to understand why are we doing this. So log of y, when you differentiate, you have 1 upon y times dy upon dx, and now you can start differentiating all the factors. So we have 3 as a constant which can come out, so we have differentiation with x times log x, which will be, if we take x as constant, we have x upon 1 upon x plus log of x as constant and then times 1 plus 2 times, now we have to differentiate log of sine x. So differentiation of log of f of x is 1 upon f of x, which is sine will go down, and then differentiation of sine x will be cos of x. It is nothing but the chain or box rule. Then again we have 1 upon log of x times 1 upon x. Now watch carefully, what are the cancellations. So we have this cancelled, so we have 1 plus log x, so we have 3 times 1 plus log x. Then we have 2 times cot of x, because it is cos upon sin x, plus we have 1 upon x log x, right? And then we have dy upon dx on the left hand side along with 1 upon y, but we want only dy upon dx on the left side, so we can multiply y on both sides and then we can have 1 upon y times y and y over here. So y gets cancelled and then we have y in the final answer. So your final answer will be dy upon dx equals to y. So what is y? Y is the initial term from where we came from, which is x raised to 3x times sine square x times log of x into the entire this term, which is nothing but 3 times 1 plus log x plus 2 times cot x plus 1 upon x log x. So this is your final answer. Now we'll take the second example, which is y equals to sine of x plus cos of x raised to 1 plus tan of x. In this case, if we take log on both sides, we have log of y equals to 1 plus tan x log of sine of x plus cos of x. Now you can say that these are two different functions, which is this you can take it as u and this you can take it as v, and then we can easily solve this. So we'll take 1 upon y times dy upon dx. Now this is self-explanatory. Now you can take first differentiation of u. So differentiation of u will be 0 plus sec square x, since once differentiation will be 0 and tan x differentiation is sec square x, and then you have to keep the v as constant. So v as constant will be times log of sine of x plus cos of x, plus now we have to take the differentiation of v. So log of f of x differentiation will be 1 upon f of x, which is sine of x plus cos of x, and the differentiation with respect to this will be sine differentiation is cos of x and cos differentiation minus sine of x into what is u? U is 1 plus tan x. So we have our answer over here, but we need to simplify this further. So we can say that sec square x time we can write as it is, sec square x times log of sine x plus cos of x, and here you can say that 1 plus tan x in this part, in this particular part, we can say that 1 plus tan x can be written as 1 plus sin x upon cos x, and then it can be also written as cos x plus sin x, everything divided by cos of x. And if you replace that, you can see that the numerator cos x plus sin x is the same as denominator over here, which is sin x plus cos x, right? And these two gets cancelled, right? So we can write here cos of x minus sin of x divided by sin of x plus cos of x, and here we have cos of x plus sin of x divided by cos of x. Now these two gets cancelled, and what we have is this cos x will also divide this term, which will be 1 minus tan of x. So finally what we have is sec square x log of sin x plus cos x, plus if we divide this we have 1 minus tan of x, and here we have dy upon dx 1 upon y. Now when you multiply both the sides by y, this y will get cancelled and your final answer will be dy upon dx, which will be y, which is the initial term, which is sin x plus cos of x raised to 1 plus tan x into the entire term which is given in black over here, which is nothing but sec square x log of sin x plus cos of x plus 1 minus tan x. So there's your final answer. So in this way we can solve different examples which are related to logarithmic differentiation. So in the next video we are going to solve such multiple number of questions from the chain rule or the box rule to differentiation of the logarithmic function. Thanks for watching.